Hello everybody. Today I'm making my a video on Needham and Schroeder protocol, which is translated in English. As in my previous video, there are so many viewers, they want it to be translated into English. So, and if you want me to talk about any other topic, please write in the comment section. And let's start the protocol. So this protocol is used to share a session key between sender and receiver using a third party called KDC. So the KDC is called Key Distribution Center. It is a third party. It is a trusted third party which is used in order to share a common key between Alice and the Bob. So let's discuss the scenario. So how many parties are there? There is Alice and there is Bob. So let's say Alice and Bob they're talking to each other for the first time over an insecure channel. So we assume that the channel is insecure and there is an intruder already sensing it. So intruder is already on the channel. So whatever Alice and the Bob are talking about, intruder can see those things. So intruder is a bad, malicious third party. And then the fourth actor in this scenario is KDC. KDC is called Key Distribution Center, which is a trusted party. So we will use this KDC to have a session key between Alice and the Bob. So it uses symmetric encryption. Symmetric means when same key is used between both the parties for encryption, it is faster than asymmetric encryption. It is suitable for longer messages. So we use symmetric encryption. Also, there is another prerequisite for this protocol that KDC already share a secret key between Alice and a secret key between KDC and Bob. So this secret key can be KA and Bob's secret key is KB. Okay, so Alice and KDC already know that KA is the secret key between Alice and KDC. KB is the secret key between Bob and KDC, which is already shared before. Now we will see how KDC share a symmetric key between all. So this is the scenario. KDC already share a symmetric key between all the users, and this protocol used for authentication also. The purpose is to share a session key. Okay. Now in this protocol, let's understand this diagram, how it works. So first of all, this is Alice and this is Bob. Alice wants to talk to Bob over an insecure channel. So it first of all goes to KDC, which is Key Distribution Center, and it is telling that IP address of A, and then it is telling to whom, which IP it wants to talk to, and N1 is a nonce. It's a random number. It is there to avoid replay attacks so that later on intruder cannot send this message again to KDC, and KDC knows that this is an old copy of old message. So first of all, Alice will send this message to KDC, and KDC in return send a bigger message to Alice. So in this message, KDC prepare two packets. Okay, so if we look at it carefully, there are two keys in this case. One is KA. KA is a shared key, secret key between KDC and Alice. KB is a secret key between KDC and Bob. So KA is between KDC and Alice, and KB is between KDC and Bob. So in this case, Bob doesn't know KA and Alice doesn't know KB. So it encrypt this letter, this big message with the key of A, that is Alice. So that means only Alice can open this message because it is encrypted with the key which Alice knows. So and in the bigger message it has sent a session key. So what is session key here? Session key is KS. It is a temporary key, which will change. It is used for a timestamp, time being, and then it will change. So this KS is generated by KDC. KDC generated a KS, put it. So KS is a shared key, is a session key, temporary key, which KDC gave it to Alice and Bob. How it distributed over an insecure channel. So it encrypted the packet where it put the key, ID of A, ID of B, and nonce 1. So kind of the same message which Alice sent, it append a new key, KS, temporary key, and then another message. It put another package inside this where it is encrypted with the B. So KB is between Bob and KDC. So this key is used to encrypt this small message, KS, which is the same key, and ID of A. So it is basically KDC is saying that this is your shared key and this is your ID and this is the ID of the receiver, other receiver, and then the same random number. And in the other package it says this is encrypted with KB, so only Bob can read this, and KS is the key and this is the ID of the sender. So what Alice will do, Alice will keep the first package and it can understand it because it is encrypted with KA. But the other part of the message, which is also encrypted with KA but further encrypted with KB, Alice will not understand it and will send this second message directly to Bob. And because Bob knows KB, so Bob will open this message and will find the KS. So now both sender and receiver will have KS, shared key, and now Bob will generate a message, generate a random number N2, and then encrypt it with the session key which is given by KDC, and encrypt it with the and send it to Alice, and Alice in return put some function on and the same random number. It function may be any multiplication or something, some operation on this N2, and reply it back to B. So now if both of the sender and receiver can understand nonce, then they are good with the KS, so they can now use this KS for the further transmission of data. So data will be transmitted after this message. So now let's go through it. So secret keys KA and KB are shared between A and KDC and B and KDC respectively. So this is what we talked about recently, that KA is between Alice and KDC and KB is between Bob and KDC. The purpose of the protocol is to distribute securely a session key KS to A and B. The purpose is we want to transmit KS to Alice and Bob. A securely acquires a new session key in step 2. The message in step 3 can be decrypted and hence understood only by B. So in the step 2, Alice will automatically understand KS, and in step 3 Bob will get the KS because this is only understandable by Bob. So step 4 reflects B's knowledge of KS. Okay. Now the purpose of step 4 and 5 is to prevent a certain type of replay attack. So let's say this is an old generated message, and if the intruder gets this message and replayed this message to B, and if B will send a nonce number, and then A already know that this message is already being sent by B, and that random number is old. So okay, sorry, for example, if Bob intruder replays Bob's message that the same number, then Alice already know that this random number is already being used, so it will avoid replay attack. In particular, if opponent is able to capture the message in step 3 and replay it, this might be in some fashion disrupt operation at B. Now this approach guarantees that only the intended recipient of message will be able to read it. It also provides a level of authentication that sender is A, but it also have a problem that it also does not protect against a replay attack. Some measures to defend. So how it is there is a problem with the replay attack. For example, if intruder get an old copy of KS, some old password, let's say, and then it replays this message, it captures this message and replay it to Bob, and then in that case it is already easily breakable because Bob will think this message is from KDC, and because they already know KS, then there is a problem. So in order to avoid that problem, we can use a timestamp message where we put a timestamp on every message, like when it is generated, and after some time the message expires. But because in a distributed environment, timestamp is not very good option, and also in emails there are very much delays, so there is a limited usefulness to this approach. Yeah, thank you for watching the video, and if you like this video, please like, share and subscribe. Thank you. Have a good day.